In the last video lecture, we were discussing about the type and order of the system. Most probably, type and order of the system, concept of type and order of the system is clear to you. Now, once you write any transfer function, right? So we are getting like 4s squared plus 5s plus 6 like this. So what does it mean actually? Why the transfer function is written like this? Or we can write it like x. So GS is written like 1 by 4s square plus 5s plus 6. Now GS means the system, means plant. So this is the input and this is the output. And we know this transfer function is nothing but the gain. That means ys by x's can be written like 1 by 4s square plus 5s plus 6. Right? And once you write this system as like this is a second order system, and you see you get the order of the system from the transfer function. You see that is the second order system. Here we solve this denominator, but we get two roots, that means two poles. So order is equal to 2. And is there any pole which lies in the s is equal to 0? See, denominator is s square plus 5s plus 6 is equal to 0. If you solve this equation, you will get two values of s1 and s2. So there is no pole at s is equal to 0. That means, or you can write it, no pole at s is equal to 0. So this type is type 0 system. So this is the type 0 system, order 2. Now this is the gain, or this is also known as transfer function, as you see. Okay, so if you write this transfer function in s domain like 1 by 4s square plus 5s plus 6, you see what is this? Basically, when you call that this is a system, that means basically there are defined kinds of elements which are interconnected together to give you a system, right? So in background of this, there is certain active or passive elements, some sources, maybe electrical system, maybe mechanical system, maybe numerical system, maybe hydraulic systems are there, right? So once you get this 1 by 4s plus 5s plus 6, 4s square plus 5 plus 6, this kind of function here, that means there is definitely certain electrical or mechanical systems are working here. So you have to get the elements of that electrical system or mechanical system, then the elements are so connected such that it is having some output and input, and the relationship between the output and inputs are described by some mathematical differential equation. From the differential equation, you will get this kind of system transfer function or system functions, right? So in order to get the system functions, we have to first model the system according to your desired specifications. Either it can be electrical system or mechanical system. Normally there may be hydraulic system, there may be pneumatic system, but most of the cases if you just model the systems in defined electrical and mechanical parameters by using, then this will be more than sufficient to learn what is mathematical modeling and how a system can be modeled by using the differential equations, right? So here in the next part we will just discuss about the mathematical modeling of electrical system and mechanical system. First of all, we will like to have one electrical system. Electrical system means there are the parameters. Normally in electrical system, what are the different parameters we do have? One is resistance, one is inductor, another is capacitor. These are the three major elements used to design any kind of system. Maybe R and L in series, maybe R and C in series. We all know about this. Maybe R, L and C, those three are in series. Maybe R, L, C, these three are in parallel. So depending upon the series parallel combinations of these three elements, along with some voltage sources or current sources, we get the electrical network, right? We know the basic concepts of network of any electrical system from the network theory. So we are going to have some mathematical modeling of electrical circuits using the concepts of KCL and KVL. By using this KCL and KVL, these are the two tools which are normally used by the electrical engineers or electronics engineers to solve any mathematical problem related to the circuits which comprises of the resistance, inductance, and capacitance. Either they may be connected in series, may be connected in parallel, and there are some voltage sources. Here, first example we're taking for modeling of the electrical system as one RL circuit. This is one RL circuit with resistance R and inductance L. These two are connected in series, and this is your forcing function. This is known as these are the terminology uh, is known to you. This is your forcing function. Actually, forcing function is that which drives the system to work. And once this VI and all the parameters you see are in time domain. That means VIT, this is the function of time. With respect to time, this voltage, supply voltage is varying. Now, if this voltage is applied, that is, if this is your forcing function, then what will happen? How to solve this problem? First of all, you have to consider, say, for example, IT is the amount of current passing through it. As you see, this R and L, they are connected in series. What happens? This IT will be flowing through R, and also this is flowing through L. Now, we may say that we want to get the voltage across the inductor, right? So we may want to get the voltage across the inductor, that is we denote as V0T, right? So in order to get the voltage across the output, that is L, or in order to get the transfer function, we have to just write either KVL or KCL. Here you see this is your forcing function VIT, right? This minus voltage drop across R. What is the voltage drop across R? I into R. What is the voltage drop across L? L di dt, right? Voltage drop across D, L is normally L di dt, and IR is the voltage drop across resistance. So this minus voltage drop across R minus voltage drop across inductor will give you the overall voltage of the loop, that is equal to your J, right? So that is the KVL, that's just voltage law, and we get VIT equal to IR plus L di dt, right? And you see what is the voltage across inductor? Voltage across inductor is equal to VL, we can write it is equal to L di dt, right? So L di dt is the voltage across the inductor. So from these equations we get VIT is equal to IR plus V0T. So this is the voltage input, voltage output, and current relationship from this point. And in other case also, if you want to get the transfer function from here, what you have to do? You have to get the actually say this is the equation number 1, and in that case you have to get the Laplace transform of this equation on both sides, right? So if you want to get the Laplace transform of 1, so Laplace transform of equation 1, right? What we get? If you get the Laplace transform, we get VIS equal to IR. I is a function of time, so ISR plus SIS into L, because L didt first order differentiation of didt, Laplace transform of this, you may write it Laplace transform of didt is equal to S L I S, right? So if you put here, the value of IS becomes VIS by R plus SL. So this is the expression for current in Laplace domain. Okay, and if this is the current passing through L, then L into didt, L into didt is your V0T. So voltage drop across the inductor, that is VL, that is equal to your V0T, right? So that is the output of this system. We get is at the input, and this may be your output. So what will get? You will get V0T is equal to LDIDT. Again, this may be your equation number 2. And if you get the Laplace transform of equation number 2, what you will get? Laplace transform of 2 will get V0S equal to SLIS, right? So SLIS. Now putting the value of IS from this to there, you will get V0 equal to VIS I plus SL into this is your IS into SL, right? So you get this is V0S. Now V0S by VIS, what is the value of it? V0S by VIS will give you SL by R plus SL, right? So I repeat this term. This is our network. We have considered as RL network. This is R, this is L, and this is your VIT forcing function input. IT is the current flowing through is, and V0 is the output. And from the previous slide or previous section, we see this is V0 by VIS. What we get SL by Y plus SL. This can be written like this form. This form is to be obtained by using this mathematical just expression. Divide this numerator denominator by S into L to get this type of structure. And you see, our aim is to get the transfer function. What is the definition of transfer function? Transfer function means the Laplace transform of the output divided by the Laplace transform of input when the initial conditions is 0. So Laplace transform of output is V0S, Laplace transform of input is VIS. This is equal to SL by R plus SL. Now you know the value of R and L. Maybe, for example, you design the system such that R may be 10 ohm and L may be 0.5 Henry, right? If these are the two parameters, then how your system will look like? V0S by VIS is equal to 0.5S by 10 plus 0.5S, right? So this can be written like, if you divide the numerator denominator by 0.5, so this will be 0.5 means this is 20 plus S by S plus 20. So what kind of system is this? And what are the poles and what are the zeros and what are the types of this? If you take any RL circuit, electrical circuit, that means once we write like any transfer functions, what we write, we are writing like S by S plus 20. Then maybe the system is a series RL circuit where the value of R may be 10 ohm and maybe L 0.5 ohm, right? And here you see this pole. What is the pole? Pole means S plus 20 equal to 0. So S is equal to minus 20. So in the S plane, you may put the value of S is equal to at minus 20 and 0. How to get the value of 0? S is equal to 0. That means there is 1 0 at S is equal to 0 and 1 pole at S is equal to minus 20. So this is the pole 0 configuration, and there is no pole at S is equal to 0. So at S is equal to 0, no pole. That means what? That means this is a type 0 system, and as there is a single pole in the from the denominator we get the system is a type 0 first order system, right? So now you can get some idea about the transfer function, because everywhere in future whenever we will write any system transfer function, that means in background there is certain network is actually working, maybe electrical network, maybe mechanical network, and so on. So if you discuss, I will discuss more to electrical network to model how to model the electrical network like this. Next step, I will consider a circuit which is normally a series RLC circuit, right? Series RLC circuit means where the resistance, inductor and capacitor, they are connected in series. I repeat this step. We are considering one series RLC circuit where this is your forcing functions, this is R, this is L and C. Because this series RLC circuit concept of this is very much important and will be utilized for further analogy with the mechanical system. So you have to just have some clear about idea about this. So this is your V0t. Now V0 is by VIT. V0 is by VIS. What is this? V0 is nothing but the voltage drop across the capacitor. That is the Laplace transform of V0t. That is your V0s, and you get this is V0I. Sorry, VIS. So V0s by VIS will give you the transfer function for the particular system. And you see, if the IT is the amount of current passing through it, definitely the voltage drop across this resistance will be R into I, and voltage drop across the inductor will be L into didt, and voltage drop across the C. What is this? This is 1 by C IDT. Now, if you get the Laplace transform in these three terms, directly what you get this R into IS. This is the Laplace transform form of this RI, and once you get the Laplace transform, you get ASL IS, right? And this is 1 by C IS by S. These are the three terms. Now, coming to this, the voltage equation KVL corresponding to this is V0 IT VIT minus R didt, that is voltage drop, minus L didt minus 1 by C IDT equal to 0. From here we get VIT, that is voltage VIT forcing function equal to RIT plus L didt plus 1 by C IDT, right? Now from this what we get, this if you Laplace transform on both sides, considering the initial conditions is equal to 0, you get VIS is equal to RIS plus SLAS plus 1 by CS IS. From this what you get? You get IS is equal to VIS by R plus SL plus 1 by CS. That's simple as that. So once you get this IS, from that you can get the output voltage V0S. How to get the output voltage V0S? That I am going to discuss. For that you have to write the differential equation of the V0T across C. That is the mathematical equation you have to write. So what are we getting? This is V0T, that is the voltage across capacitor, 1 by CS IDT. And taking Laplace transform on both sides, V0S will be equal to 1 by C IS by S. That means IS by CS. Now putting the value of IS here, what will get? You will get V0S is equal to 1 by S, sorry, 1 by SC IS. Instead of IS we write V0S by R plus SL plus 1 by CS, right? So from that what we get? You get the V0S by V0IS is equal to 1 by R plus SL plus 1 by CS into C, right? So you get 1 by R SC plus S square LC plus 1. If you just rearrange this in the form that highest power is taken first, so this is S square LC plus S into RC plus 1. You see this S into L in C, R into C. Now if the value of R is equal to say 1 unit, L is equal to 1 unit, and C is equal to 1 unit, then what will get? This V0 is by VIS will be equal to S square plus S plus 1, right? So what is our motto? Our motto is to get the relationship between the input output. That means if this system is like this, so GS, we may call here some output, some input is there, right? Input GS. So what is this? This GS means 1 by S square plus S plus 1. That means if I write arbitrarily that a transfer function of the system is taken, what does it mean? That doesn't mean, that does mean or that means that kind of electrical system, maybe series RLC type circuit, is working here as your system, and you are applying this input here and you are getting the output here. This is the relationship, and from here you see S square plus S plus 1 in the denominator. From this denominator, if we solve this, we get the two values of S, because this is S square plus S plus 1. So two values of S means this is a second order system. So if you just compare these two cases, previous cases RL circuit was there, and in this case this is RLC circuit, right? In the previous classes, previous part, we have discussed the series RL circuit, and here I have discussed the series RLC circuit. And what is the difference I found? What is the difference for series RLC circuit or series RL circuit, and I know that is RLC circuit? We get this is a first order system and this is a second order system. This is the first difference I can see it. And how this difference is making, actually if you can note these two structure, you see the R is common to both, L is common to both, C is not there in RLC circuit. That means, and we know this L and C, these are the storage elements. These are the known as the storage elements. So if the number of storage elements increased, that means order of the system is also increased. That is very much important criteria of the electrical circuit network. You should know that if you say there is two number of capacitors, two number of inductors, that means maybe series connected, maybe parallel connected. Number of inductor increases, that means number of the order of the system increases. Number of capacitor increases, that means the order of the system is again increased. That is why in case of RL circuit, that is a single storage element, so that is contributing a first order system. In the series RLC circuit, there is two storage elements, one is inductor, another is capacitor. So what we'll get, we'll get the order of the overall system is second order system. So that is the way how you have to get the actually modeling of any electrical network. That means by using either KCL or by using KVL, you have to get the relationship between input and output. First of all, you have to identify what is the output and what is the input and what are the elements inside the network and how this network is actually described by some differential equations, right? So if I can see a parallel resistor inductor capacitor circuit, so how the mathematical model will look like, right? So whether this can be given as assignment or I solve. Anyway, let me solve this for this time. But other than this kind of system, any other circuit can be given to you, and for that you have to solve it, right? For this time being, I am just write down the equations. That means the governing equations I will write down, and you will get the corresponding actually the transfer function of the system, right? Fine, it will be okay. So parallel analysis circuit. Parallel analysis circuit means R, L and C. These are the three parameters which will be connected in parallel, right? So I'll just draw the circuit. This is R, this is L, and this is say your C. So once these circuits are parallelly connected, then we will use the forcing function as your current IT. Say IT is the current which is flowing through it, and there are certain nodes from where this current is divided into three parts. This is IR is the amount of current passing through this resistance, IL is the amount of current passing through this inductor, and IC is the amount of current passing through the capacitor, right? So if we go on KCL, that means node analysis, what we find, this IT will be equal to nothing but IR plus IL plus IC. So depending upon the situation, whether this node analysis or mesh analysis is used, whether the voltage source or current source is used, depending upon that, you have to apply corresponding either KVL or KCL. Here, as the current is the forcing function, and you see clearly it is indicated that the total amount of current is divided into three parts as they are parallelly connected. So what happens? This total amount of current is passing through the three nodes. That means we will have to use the KCL. Okay. So IT is the amount of current, that is IR plus IL plus IC. And see, actually, what is the voltage across the capacitor? that is your output voltage. Say we have identified this is your input and this is your output. So according to that, what you have to get, you have to get the transfer function like V0S by Is, because here we get the output is V0S and V0T is the voltage across the capacitor. And for that, first equation is this, and this equation is to be modeled like this. If this voltage is V0T across capacitor, definitely voltage across L will be equal to V0, and voltage drop across this VR will also be V0, because they are parallelly connected. As they are all parallelly connected, so voltage across this capacitor is say V0, voltage across L will be V0, and voltage across R, that will be also V0. Fine. So next equation is that you have to find what is this IR. Once you get the V0, so IR is the voltage, sorry, the current passing through the resistance. What is the voltage drop across this V0? R. Impedance of this path is R. So you get this V0 by R. This is your IR. Fine. This is your IR. Next, if I say this L into DI dt, DIL dt, L into DIL dt is equal to your V0. Right? So what will get? You get L into DIL is equal to V0 dt. So DIL, just basic 2 or 3 equations you have to know, and then you have to arrange this or rearrange this. So DIL is equal to V0 by L dt. Right? So if you integrate this, you can get the value of IL. That is one procedure. And second procedure, that is quite easy procedure, I will ask for, that is you get the Laplace transform on both sides. That will get IL SL is equal to V0S. Right? Similarly, here also IS is equal to V0S by R. Laplace domain also you can solve it, because we have already used to get the easiest solution in Laplace domain by using the algebraic manipulation, as I have discussed. Next part is that this capacitor part. Similarly, what is this 1 by C integration of IC dt, that is equal to your V0T. Right? So if you get the Laplace transform on both sides, once you get IC by CS, IC by CS equal to V0S. Right? So you get the IL from here, you get the IC from here, you get the IS from here. And if you get the Laplace transform on both sides, this IS will be equal to IRS plus ILS plus ICS. Right? And putting this value, what will get? IS. Right? This is your IS equal to, directly you can get, this is your V0S by R. IL means V0S by SL plus V0S into CS. So this is your IS, and here from this you get, so you get, that is your IS by V0S equal to 1 by R plus 1 by SL plus 1 by plus CS. Here you just solve it and inverse of it to get V0S by IS. So V0S by IS, that is your desired transfer function, and that you can get directly from this mathematical analysis. That means these are the 3 main steps. One is to get either voltage or to get current. And across the inductor, what is the voltage drop? L di dt. Across the capacitor, what is the voltage drop? 1 by C integration of I dt. These are the 2 terms required. And in the differentiation part is that if you just get the Laplace transform of it, we get S into something. And if you get the integration part, the Laplace transform will get 1 by S into something. So that is the mathematical modeling. We have done the series RLC circuit, we have done the series RL circuit, we have done the series parallel RLC circuit. That means the electrical network consists of either current or voltage, either inductor, resistance, capacitance, and they are series connected either, or they are either maybe parallelly connected. So whatever be the connections, you have to find out the transfer functions, right? So the next part of this lecture video, I will be discussing about the mathematical modeling of the mechanical system. So before going to the next part here, from this lecture, what you have learned, that I want to know. That is the part of the our proposal, that in every sections I'll be giving you some assignment. So the thing is that here the assignment task is you have to find the mathematical modeling and transfer function of the system given by some electrical modeling. What is this? And this is here, I see, I can write it like this. This is your L1, this is R1, C1, this is 1 by C1, and that is 1 by C2. This is 1 by C2, and this is your VIT. So this is one electrical network which is having one inductive path, two capacitors path. The value of capacitance is given by 1 by C1, and this is say 1 by C2. Now you have to get the say voltage drop across this is equal to V0T, and this is VIT. So by using the mathematical calculations or mathematical modeling, that means you have to write the differential equation corresponding to the voltage drop or some current maybe passing through the different paths. Here you can use the mesh analysis. I can give you hint. This is mesh analysis. This is current may say, you can say it I1T, you can say it I2T, and next this is loop 1, this is loop 2. Write down the KVL for loop 1 and loop 2 and solve for the parameters to get V0 is by VIS. Once you get this V0 is by VIS, that is your transfer function. That means whatever you will talking about some transfer function like 1 by 4s square plus 5s plus 6, or 4s plus 2 by 3s square plus 6s plus 9, like that. That means these are the coefficients basically. But you have learned, say 4s plus 2 by s square plus 3s plus 4. If you can say or you can simplify it by using 2. Since this is a transfer function given to you for analysis. For the next part of the onwards, we will be analyzing the different types of systems. System means it is having a transfer function. From this analysis, what do you see? This is a type 0 system, and this is a second order system. If this is modeled by electrical parameters, how can it be modeled? That means you see the coefficients. This 1 coefficient of s square, this is the 3 coefficient of s, this is 4 coefficient of s to the power 0, right? This is s to the power 0 means 1, so coefficient of s to the power 0 is equal to 4. So these are the coefficients, how these coefficients are coming and what are the role of these coefficients, right? Once you model the system, you have to know the roles of these coefficients, right? And these coefficients are coming basically from this L, R, C and all this, right? That means if a system is to be stable, then what are the values of this 3, 4? Maybe this system is not stable, maybe the system is stable. If the system is not stable, then change the parameter in such a way the system can be stable also. So for stability analysis and other things, you have to design the system in such a way so that these parameters actually you have to change. So this is the way how the mathematical modeling of the electrical systems are done. In the next part of the video, we will be discussing about the mathematical modeling of the mechanical system. Okay.